Good day, guys. Welcome. My name is Amanda Deborah, and today I am going to be talking to you guys about the web development project that we have been working on. So, without any further ado, I'm just going to first introduce the rest of my team that I've been awesomely working with for the past few weeks. So, before I go on, the name of my team is Deborah Poynton. Sorry about that. Firstly, we have Dimpo Molife. Dimpo is the one that is going to be explaining to you guys about the object persistence and how we went about into handling our data population. So, and also we have Noglunga Msabala. She's the one who's going to get into details about our RDBMS, how we're handling our data, how the books are stored, and all that information that you might need in order for you to be secured and how you will be able to find your books in this app. Right, and we also have Yongama Kologoto. Yongama is the one that is going to cover all the concept about the tests, as well as the unit testing and the overall performance of our app and how we went about testing and how we succeeded. And also Amanda, lastly, which is me, I'll be handling the HTTP API part, how we actually connect it and how we connect the user's request with and how we deliver the user's request as per request. Okay, now let's just get right into it. Okay, so as for the project overview, well, here I'm just going to tell you guys about the purpose of this group project. In this group project, we were asked to actually create an online library that will be easily accessible. You can actually request using your title, your description, or a different book ID. You know those I'm not sure if I'm saying it correctly, but yes, those ID for your books. So you can use all that information in order to be able to access the book that you need. So this project is going to do exactly just that, and we have incorporated like a couple of topics which are very crucial fundamentals in order to make this project a huge success. So firstly, we'll have the HTTP APIs. The HTTP APIs are going to handle the connection, or should I say the communication between our library server as well as the user's request. And also we'll have the relational database design and SQL. That is where we are going to actually try to create our whole new information and store it there. Or should I say our data table in a database is going to be found there on a relational database. And also we'll have object persistence which actually helps us use objects that will be able to outlive the application process. They can also be saved to a data store and can be recreated for a later time usage. And now lastly, we've used HTML and CSS for our user view side. Now with all that, I think I've just covered the project overview. Now we'll just go right into the development tools that we have used. So in the development tools that we have used, I'll be talking a little bit more about what we used, how we used it, and why we used it. Okay, so we have a few lists here. We have Java libraries that actually helps make our life easier. It makes it easier for us to actually program. We don't have to go look up for things. You can just import your libraries and things will be much easier for you. And then we've used the Javelin. The reason why we use Javelin is because we are going to be using the HTTP APIs, and Javelin is mostly a framework that is mostly used for HTTP API communication, or it is used to handle all those HTTP API requests. And also we've used the Maven, Epic Maven. Well, as we all know, that Maven is a software project management and comprehension tool that is best known for dependency management, right? So the reason why we use this, remember, when you are a developer or you are developing a project, it's like a continuous integration. You keep on merging, you keep on coding every time, and you sometimes lose track of time, and you might need to update those dependencies. So Apex Maven helps us a lot with that, because it can actually even automate, or it automatically updates or upgrades the dependencies. It can be able to self-manage, should I say. So, and also it has the simple setup, consistent usage across all objects as well. So that's the reason why we used Maven instead of every other. And then now we have we've also used the simple login facade for Java as abstraction for login frameworks. So remember, as time goes on, we will have to like try to log in and use all this information. So the SLL4J allows end users to plug in the desired framework and deploy in time. And yeah, so, and also we have SQLite. That is what we're going to be using for our database. And IntelliJ, the reason why we used IntelliJ is because it supports version control. Remember, as developers, we are changing version. As you're done with this iteration, you move into the second iteration on the very same project, but developing the versions. So IntelliJ, we chose IntelliJ specifically for that reason, that it supports version control. And as for the Git services that we've used GitLab, since it is our central Git services that we're using on campus. And as for code sharing, we have tried as a team to have our daily stand-ups every day, so that we can keep each other up to date as to what we are doing, and it's Slack as well as WhatsApp. Now let us move on to the HTTP API. So in HTTP API, I'm going to explain a few concepts. Now remember, an HTTP API is a protocol that describes how your client can access resources and what methods work with our architecture, right? So you can essentially think of it as a translation guide from one technology to another. Right. So an HTTP, however, is an API that uses hypertext transfer protocol as the communication protocol between two systems. And also, it exposes endpoints as API gateways for HTTP requests to have access to a server. Now remember, I did say we have used Javelin in order for us to actually have this HTTP connection. And now let's move on to our structure. So here I just showed you guys a little bit of structure on how we develop the classes on handling the HTTP, or handling the user's request on our group project. So here the user will be able now to actually log in a request. They will be able to request for their desired book using the title or the description. As you can see here on the task class, that we have our attributes, which is an ID and a description. So if a user gets this ID, so this ID could be your USIN ID, and the description may be like I don't know, anything that can be written in a book. What could possibly be? Right, I'm so used to computers, I even forget about books. Okay, cool. So okay, so And also we'll have the task database. The task database now is actually the class that helps us to actually add information into our database. So here you can add tasks. Remember, if you're adding tasks, that means you're adding book into your database. So if you have a new book, it will pass through this task database, and then it will be passed on as your information that you going to use, or that might be reused at a later stage. So on my side, guys, I would like to say thank you so much, and we'll have the next chapter, which is RDBMS. Thank you so much.
And today I will be tackling everything relational database design and SQL. So first things first, what is SQL? SQL is an acronym for Structured Query Language, and it's a programming language that is used to work with databases. Most commonly, SQL is used to work with relational databases. A relational database is a type of database in which data is stored in the form of a table. So I'm just going to go right ahead and dig deeper into the code. Here we go. Great. So when we're using SQL, we're basically creating tables. So I'm just going to show you this example. Here we're creating a table by the name of books. We're using an ID. An ID is a number, so therefore we're using an integer, and it's a primary key. We're using auto increment because we want a new number to be generated every time a new record is inserted into the table. Not now, it cannot be left with no value. So basically, a foreign key is a field in another table that is used to reference a primary key in another table. So this is how we went ahead and created a table called books. So this is from the relational database management system. We use the all books validator. Our all books validator is basically showing us what is expected from what we just created. So this method shows how our books table is actually structured and what it contains. So it validates whatever we're creating in the books table. I'm just going to go ahead and find our history books. With our history books, what you find here is that now we're using inner join. Inner join in the sense that there's a relationship between the two tables in a way. So in this code, we're trying to find all books with a description of history. So from the RDBMS, we're going to use history books validator. The history books validator is what validates whether in that way in that table can we find history books, right? I'm gonna go ahead and just show you insert. When we're inserting into a table, we are inserting new record, right? So in this case, we're inserting into books and we're using title and journal code. This falls under title and this will fall under the journal code. Gonna go ahead and just run our test and database test. I'm just gonna go ahead and run that quickly. So that is all from me with regards to relational database design and SQL.
Okay, thank you for the opportunity. My name is Deborah. I've chosen the topic of persistence, whereby I'll be presenting what we were doing for persistence. So in persistence, we're supposed to create a table using the JDBC code. So here we actually created a table for genres, which had two columns, which is code, which was a text not now, also primary key, description, and text is also not now. Then we used a prepared statement. A prepared statement is actually you want to connect to the database and stuff. So if it's being executed, then it will return true. If not, it should return an exception error. With creating books, it's the same way as creating genres. But the only difference is that we accessed the genre table. Yes. And for 3.2, we're supposed to insert the data to the genre. So we actually put in the data or put in the values in the genre table. So in order to put the data, we have to connect to the prepared statement, then we insert the values in the genre. Then it should give us the code using the getters, should give us the code, and also we should get the description. If this is not done, it should give us an error. With also the 3 parts, the 3.3, the 3.3 part, we're supposed to find all the genres. So when you're finding every genre, you have to select from the genres. So you had to connect first using the print statement, connect to the data after connecting, then you select all the genre. So the star means everything from the genre parts. Yes. So if you found the everything in the genre part, you had to add it to the list that was created, the new list. So we actually found the code and found the description, the 2 columns, and after we added it to the list to actually create a list of every genre. But also the find genre like. So we're actually wanting to find genres with similar alphabets in the middle. So if, for example, it has similar alphabets in the middle, it should print out. So we're selecting the code and description from the genres where description is the same in the middle. So it should print us the same description in the middle. Then the find books and genres, we wanted to just find select the title, description from the books, and also the genre. So we actually want to find the same books, the books with similar genres. So that's what we wanted to find. Then when it comes to testing, all our tests passed when we were running them for the persistence test. But the test I've chosen was the bed creation. So when you create a bed table, it should fail since there is a test for bed creation. Then we have a test for creating genres, which actually test if the table created has genre. We have one for creating books, would actually test if the the table for books created has books. And then also with find all genres. So the find all genres table, it actually selects and check if you have all the genres in the table. As I said, if you find all genres, you have to select all of them and check if genres have all these lists that we have. Yeah. And also with the find genres, like it's the same one that I was saying, if it has a similar description, has the same alphabet in the middle, it means that it has genres like this. Thank you so much. Any questions?
Hey everyone, this is Yongama Mkologoto, a student from Within Code, who is in Deborah painting group. This video serves as a continuation on the web dev project, and its focus will be all in testing. The test plan for this project is based on testing using JUnit framework and JSOAP framework. We put our focus on unit testing and end-to-end testing for this project. Since our project is more of a full-stack app, we created 3 sub-projects that will be tested under this one huge project. We will be testing these 3 projects if they are working according to their requirements. So here I'm going to run the test for our API. So let me run the test for our API. So I'm testing our API here. then here I'm testing our database, running all of our tests from our database. And then here also testing our database. Here I'm running all of the tests for our database. Now I'm running tests for our website, all of the tests for our website. So all our tasks are working according to their requirements. So what I like about us, we didn't deviate from the testing plan. So everything is working according to what it's supposed to do. So here I can show the the results, all of the test. Okay, let me run it using Maven test. Okay. So here I will say Maven test, and I'll see all of the test. So since while the tests are running, here they are done. So we have 0 failures, we have 0 errors, we have 0 tests skipped. All of the 28 tests passed. So which means our app is running according to the specifications. Thank you. Bye.